Let's unpack this. Breviceratops, shorthorn face. It's got a certain ring to it, doesn't it?
It really does.
And that's our entry point for today's deep dive. We're going back, way back to the late Cretaceous in Mongolia to explore this, well, fascinating dinosaur. Maybe not a household name, but definitely one with a story.
Absolutely. You know, the T-Rex, the Triceratops, they often steal the spotlight. But our goal today is really to dig into the science behind Breviceratops.
Yeah.
We'll trace its discovery, sort of unravel its classification, and highlight those specific features that, make it unique.
Think of this as your shortcut, basically, to getting a solid handle on this creature, where it fits in without getting bogged down in jargon.
Exactly. We want to give you that insightful understanding. And just so you know where we're coming from, we're relying on the scientific bedrock here.
Right. The actual research papers.
Yeah, the original descriptions and the reclassifications. So specifically that 1975 paper in Paleontologia Polonica and the really important 1991 in the Paleontological Journal, plus some more recent work on classification, too.
So you get the latest thinking. It gives you confidence in what we're discussing.
Right. It's all about extracting the key stuff from these sources for you.
Okay, so with that solid foundation laid, let's rewind. Where did this short-horned face first, pop up?
Well, the story starts, interestingly enough, back in the 1960s.
The 60s, wow.
Yeah. There was a Polish scientific expedition out in Mongolia's Gobi Desert, specifically the Nemegt Basin, which is just, legendary fossil territory.
Oh, absolutely.
And it was that team who first unearthed these crucial fossils. It really shows you how international and collaborative this kind of discovery process is.
You can just picture them out there finding these ancient bones. So they find these fossils in the Gobi. What happens next? How does it get its scientific identity?
So the first formal write-up was in that 1975 Paleontologia Polonica paper we mentioned. Two paleontologists, Teresa Marieska and Helska Osmolska, they studied these finds, and initially they thought, okay, this looks like a new species of Protoceratops.
Ah, Protoceratops, a name people might recognize.
Exactly, a fairly well-known genus already. So they named this new species Protoceratops kozlowski.
Kozlowski.
Yeah, honoring Roman Kozlowski, a really important figure in Polish paleontology. So at first, it was seen as just another type of Protoceratops.
Okay, so it starts its scientific life under that umbrella.
Yeah.
Where exactly were these specific first fossils found? And what did they actually dig up?
Right. The key specimen, what paleontologists call the holotype, the main reference fossil that one's cataloged as ZPL MGDI-117.
ZPL MGDI-117.
Got it. And it came from a specific spot in the Nemegt Basin called Kulsan. That area is part of the Barun-Goyot Formation.
Which tells us the age, right? Late Cretaceous.
Precisely. Late Companion Age within the Late Cretaceous. And this holotype, it was a pretty significant find. It was a partial skeleton of a juvenile. So the body bones, mostly, but crucially, it included the skull, too.
Oh, nice. Skull and skeleton, even from a juvenile, that's a great start.
It really is. Gives you a decent picture right off the bat.
Were there other bits and pieces found around the same time? Other fossils they linked to this new Protoceratops species?
Oh, yes, definitely. Besides the holotype, they found several other remains they also assigned to Protoceratops kozlowski.
Okay.
These came from Kulsan, but also another nearby spot called Hermansav.
Ah, two localities.
Yeah. And we've got more catalog numbers, like MGDI-116, that was a skull and lower jaws from a small juvenile, so showing different growth stages.
Interesting.
Then MGDI-118, bits of skeleton and lower jaws from another juvenile. MGDI-119 was a lower jawbone, a dentary, and some vertebrate pieces. And then there were just isolated bits, like MGDI-20, 21, and 22 jaw fragments, teeth, the kind of smaller finds that still add valuable info. MGDI-21 was neat part of an upper jaw with 4 teeth from a young one.
So a decent collection of material overall, leading them to think it was a second Protoceratops species.
Initially, yes.
So how did we get from Protoceratops kozlowski to Breviceratops? What changed? Who made that call?
Right. This is where the scientific process gets really interesting, how things evolve. Fast forward to 1990. A Russian paleontologist, Sergei Mikhailovich Kirzanov, he took a fresh look at all this material.
Okay.
And his analysis led him to believe, hang on, this isn't just another Protoceratops. This is different enough to be its own genus.
Ah, a bigger distinction.
Exactly. So he proposed the new genus name, Breviceratops, and like you said at the start, brevis for short in Latin, and then Ceratopsia, short horn face. That became its official genus.
Makes sense. Now, I remember reading that Kurzanoff also included those fossils from the other site, Hermannsav, under Breviceratops. Did that stick?
Ah, good question. And this is where it gets even more refined. It's a perfect example of science correcting itself.
Okay.
So Kruzanov initially did lump more specimens in, especially from Hermannsav, but later, more detailed studies focusing really closely on that original holotype from Kulsan.
The ZPL MGD-I-117 one.
That's the one. They noticed something important. The holotype has what are called primitive premaxillary teeth. These are teeth right at the very front of the upper jaw.
Okay, primitive teeth. What's the significance?
Well, the significance is that this feature doesn't match up with another related dinosaur, Bagoceratops. Bagoceratops has a more derived, sort of later evolved dental setup. Those Hermannsav fossils looked more like Bagoceratops in that respect.
Ah, so the teeth didn't line up between the holotype and those other fossils.
Exactly. So the consensus now is that most of those fossils Kurzanoff added, particularly the Hermannsav ones, they actually belong to Bagoceratops.
Wow, so Breviceratops is now much more restricted.
Pretty much. It's mainly based on that original holotype and maybe that other Kulsan specimen, ZPL MGD-I-116, the juvenile skull and jaws. It really narrows down what we confidently call Breviceratops.
That's fascinating. A detail like primitive teeth completely changes the picture. Shows how careful you have to be.
Absolutely. It suggests these early ceratopsians were maybe trying out different ways of eating, different specializations. Even subtle skull details matter hugely for figuring out relationships.
Okay, that's a great look at the discovery and the naming saga. So now we have a clear idea of what Breviceratops is and isn't. What can we actually say about the dinosaur itself? What did this short-horned face look like roaming around Mongolia back then?
Well, it was definitely a protoceratopsid dinosaur living in that Late Cretaceous Mongolian environment. Now, about the short-horned face name.
Yeah, less literal maybe.
Perhaps. The scientific descriptions we have don't really focus on big, obvious horns like you see on a Triceratops. It's more about the overall skull structure and a unique mix of features found there.
Okay, so the name might be more about the general skull shape or some less obvious bumps rather than actual pointy horns. What were these unique skull traits then? What set it apart?
There are a few key things. One, as we just discussed, is those primitive premaxillary teeth right at the front.
Right, the ones that help distinguish it from Bagoceratops material.
Exactly. And interestingly, that's a trait also found in Protoceratops and Druzy, the classic Protoceratops. So maybe it's an ancestral feature it held onto.
What else?
Another big one is an antorbital fenestra.
Antorbital fenestra. This sounds technical.
It just means an extra opening, kind of like a window in the skull bone called the maxilla, just in front of the eye socket.
Okay, an extra hole in the skull. Was that unique to Breviceratops?
No, actually, Bagoceratops had one too. But, and here's the crucial bit.
There's always a but in paleontology.
Almost always. The shape of this opening was different. In Breviceratops, this fenestra, this window, was narrow, sometimes described as almost straight-edged or slit-like.
Whereas in Bagoceratops,
It's typically broader, more rounded, or oval, so that specific shape difference is a key diagnostic feature separating them.
got it. Narrow window in Breviceratops. What else defined its skull?
Well, like other protoceratopsids and ceratopsians generally, it had a neck frill.
The bony shield at the back of the head.
That's the one. Formed by the parietal and squamosal bones. In Breviceratops, it's described as moderately pronounced. Not super elaborate like the later giants, but definitely there. It's a family trait.
So it's that specific combo. Primitive front teeth, the presence and narrow shape of that skull window, plus the moderate frill. That's the Breviceratops identikit, sort of.
That's a good way to put it. Yeah, that's the combination that defines it based on the known fossils.
Okay, let's zoom out a bit then. We know it's a Protoceratopsid. Where does that fit in the grand scheme of dinosaur evolution, the bigger family tree?
Right. So the big group is Ceratopsia. That includes all the horned dinosaurs, famous for their parrot-like beaks. Mostly herbivores, really successful group in the Cretaceous, especially in North America and Asia.
Okay.
Within Ceratopsia, Breviceratops sits in the family Protoceratopsidae. These are generally earlier, smaller ceratopsians. They usually lack the really big brow horns or nose horns and the super elaborate frills of their later cousins like Triceratops or Starkosaurus.
So kind of like the ancestors or early relatives of the big famous ones.
Pretty much, yeah. Understanding these guys helps us see how those later, more extreme forms evolved. It shows the steps along the way.
And we mentioned sources. There was a specific 2019 classification mentioned by Łukasz Czapicki. How did he place Breviceratops within that Protoceratopsidae family?
Ah, yes. Chepieski's 2019 analysis is really helpful here. His work looked closely at the relationships within the family.
And what did he find for Breviceratops?
According to his analysis, you've got the two main Protoceratops species, Andrewsaraci and Helenicornis, sort of branching off as one group.
Okay, they're related.
Yes. And then on a slightly separate branch, you find Breviceratops and Bagaceratops grouped together as closer relatives to each other than they are to Protoceratops.
Ah, so Protoceratops is like an earlier offshoot, and then Breviceratops and Bagaceratops are like sister genera, closer cousins.
Exactly. If you picture a simple family tree, Protoceratops splits off first, and then the branch leading to Breviceratops and Bagaceratops splits off next, with those two being the closest relatives on that particular twig.
That branching analogy really helps visualize it. Okay, great. So let's try and boil this all down. For you listening, what are the absolute must-know takeaways about Breviceratops from this deep dive?
Okay, the key points. 1. Breviceratops was a protoceratopsid dinosaur from Late Cretaceous Mongolia.
Okay.
2. It was first named as a species of Protoceratops, but later got its own genus name.
Right, the renaming.
3. It's distinguished by specific skull, features those primitive premaxillary teeth, and importantly, that narrow antorbital fenestra, that skull window. That shape helps tell it apart from Bagaceratops.
Got it. Teeth and window shape.
And 4, classification-wise, it sits in the Protoceratopsidae family, and current thinking suggests it's most closely related to Bagaceratops, after the main Protoceratops lineage branched away.
Fantastic summary. Okay, so now that you've journeyed through the details of Breviceratops with us, here's something to chew on. Consider this. How often do these initial scientific ideas, like calling it Protoceratops, get revised and refined? We saw it happen right here with the Bagaceratops material being separated out.
That's a great point. Science is constantly refining.
Exactly. So what might future discoveries, maybe more complete skeletons or fossils from different sites, reveal? Could they shift our understanding of how Breviceratops, Bagaceratops, and Protoceratops are all related? It just underlines that paleontology is this ongoing detective story, always looking for the next clue.